Does science properly acknowledge all the phenomena that exist in the world? Almost certainly not. There's a systematic tendency to ignore phenomena that aren't easily observed or created on demand, or that just don't fit in to existing theoretical ideas. The easiest way to see this is to consider phenomena that used to be rejected by science. The consensus was these phenomena didn't exist. But now we know very well that they do exist. One phenomenon that used to be rejected by science was the movement of continents. The continents on Earth's surface actually move very slowly, about as fast as your fingernails grow. And over the course of tens of millions to hundreds of millions of years, can make globe-crossing voyages. Look at this map. This shows existing continents, rearranged, fit together like jigsaw puzzle pieces. The fit is not at the current coastlines, those have been modified over millions of years, but instead at the edges of the continental shelves. And if you line up the continents this way, you can see that there are only very tiny overlaps shown in red and very tiny gaps shown in blue. Really, the fit is extraordinarily good and is important evidence that the continents actually used to fit together this way. It's not only the shape of the continents that supports this idea. Geological structures on different continents line up, as do rock types, the distribution of fossils, and indicators of ancient climate. The way the continents fit together was described as early as the 1500s by the mapmaker Abraham Ortelius, and the German meteorologist Alfred Wegener published a book-length description of all of the evidence in 1915, making the case for continental drift, as he called it. But in spite of all this evidence, the concept of continental drift was comprehensively rejected by geologists. The main argument against the idea was there seemed to be no plausible mechanism that could cause it. What we have here is a case of a phenomenon that didn't fit with theoretical ideas and therefore was rejected. The geophysicist Harold Jeffreys made a case against continental drift in his book, The Earth, in 1924. And for academic geology, that was that, regardless of the evidence. But by the 1960s, there was additional types of evidence for the movements of continents, including measurements of the magnetic orientations of ancient rocks relative to the North Pole. This map, for example, shows how the North Magnetic Pole would have had to been wandering around various numbers of millions of years ago if Siberia hadn't been moving for the last billion years, and maps of the locations and directions of earthquake movements, which actually showed continents taking tiny steps in the directions expected. There were also improvements in the theoretical picture. Instead of the idea being that continents somehow plowed through the oceanic basins, continents and oceanic crusts were described correctly as resting on deeper, stronger structures called lithospheric plates, and those can slide over the partially melted Earth's mantle, driven by convection cells releasing heat from deep in the Earth. This newer theoretical framework was given the name plate tectonics, both to describe how it worked, but also to help distinguish it from what was earlier the academically disreputable theory of continental drift. What is so striking here is that overwhelming physical evidence for what had occurred was rejected for more than 40 years after its careful presentation by Wegener, because it didn't conform to prevailing theoretical ideas. But this is backwards. Theory should be based on evidence, not evidence based on theories. As for Harold Jeffreys himself, He maintained his opposition to the idea until his death at age 97 in 1989. Next, let's consider the troubled history of the recognition of meteors, meteorites, and meteorite craters as actually existing phenomena. Let me remind you of the terminology. Meteors are streaks of light in the sky due to objects heated to glowing by atmospheric friction. Meteorites are the rocks and metal that fall. Meteorite craters are the impacts made by the rocks and stones falling. These are sometimes incorrectly called meteor craters, but really they should be called meteorite craters. This is so-called meteor crater behind me. The fact that rocks actually do fall from the sky was recognized by some for a long time. This is a print by Sebastian Brandt of the Ensisheim meteorite, which fell in Germany in 1492. And this is the meteorite itself, now preserved in a museum. But by the 1700s, the idea that rocks could fall from the sky was regarded as myth. The famous French chemist Lavoisier argued that the fused crusts found on meteorites were just due to lightning strikes, and meteors, the flashes of light in the sky, were theorized as due to somehow the burning of gases rising from the Earth, rising due to what Edmund Halley, the guy that Halley's Comet is named after, wonderfully called the gases innate levity. Only towards the end of the 1700s did it come to be accepted that metal and rocks can fall from the sky. The Hungarian-German physicist Ernst Chladni published in 1794 a book that connected meteorites with meteors and proposed an extraterrestrial origin. This book, along with some very well-documented rockfalls, eventually changed opinion. Still, the idea of meteorites forming craters on the Earth was generally rejected. Instead, there was a theory of cryptovolcanoes, volcanoes that somehow didn't contain any volcanic rock and weren't near other volcanoes. So, continental drift and meteorite impacts are two examples of phenomena that do exist but were rejected by science for decades or even centuries. The question, of course, is whether there are comparable phenomena that are rejected by science even today. In the early 20th century, Charles Fort spent 2 decades collecting more than 60,000 examples of anomalous phenomena, publishing the results in 4 books filled with overwhelming evidence that conventional science continues to suppress observations that do not conform to prevailing theories, along with his own outlandish theorizing and kind of impish ridicule of scientific pretensions. The tradition of Fort has been carried on by numerous successors with various degrees of seriousness and rigor. To be sure, evidence of the unexplained verges into all manner of screwball ideas and psychopathology. Yet there are many things in the world that clearly exist but are not properly acknowledged. The most worthy successor to Fort has been William Corliss, who spent decades of his own in the late 20th century carefully collecting and publishing evidence in exhaustive volumes. There are many varieties of well-documented phenomena that evade easy scientific explanation. Here we'll consider only 2 in depth. The phenomenon of ball lightning, which was on the edge of scientific recognition for over a century, has now more or less reached general recognition. Observations vary, but often contain some common features. A luminous ball the size of about a grapefruit appears, typically during a lightning storm. It glows with the light of less than a 100-watt light bulb, floats around noisily, burns people or things, and ends after maybe 5 seconds in an explosion that can damage buildings. An ozone smell is often present. There are more than 200 well-documented observations cataloged by Corliss, plus seemingly similar phenomena seen in various laboratory experiments. There are now also several quite technically detailed theories to explain ball lightning, but none are fully satisfactory. It's not at all straightforward to reconcile a self-contained ball of energy with the known laws of electromagnetism. Marine light wheels are another consistently reported inexplicable phenomenon. In hundreds of incidents, observers on ships report enormous spokes of light in the water rotating around a distant hub on the horizon. Sometimes there's more than one wheel with different hubs overlapping and rotating in opposite directions. The beams are often reported as curved with the concave side in the direction of motion. Almost all reports are from the Indian Ocean. A few specify that the light is a bit above the water surface. Some report that the phenomenon is affected by turning on or off the ship's radar. Most speculation is that marine light wheels are some kind of coordinated signaling by bioluminescent organisms. But how coordinated or triggered to produce concave rays? There are many reports also of luminescent bands that simply move parallel to each other. These are only two examples of repeated, well-documented, unexplained phenomena. I'll just list some others that seem well substantiated as well in case you'd like to dig deeper. There are mistpouffers, also known as fog guns, Seneca guns, brontidi, and retumbos. A muffled explosive sound is regularly heard in the distance, always somewhere else, with no identifiable source. Some, for example the Moodus noises, may be correlated with small earthquakes, but some, like the Barisal guns, are not. There are other unexplained recurring sounds, such as the upsweep, slowdown, and Julia sounds that have been detected for decades by hydrophone arrays in the Pacific Ocean. The upsweep is curiously seasonal. There are the Yellowstone Lake whispers, which are perhaps resonances of geothermal sounds, and like mistpouffers, always seem to be somewhere where the listener is not. There are also credible reports of lights caused by earthquakes, animal predictions of earthquakes, the recurring mysterious Yakima lights, Guerdon lights, and Hessdalen lights. There are falls from the sky of sheet ice, falls from the sky of fish and frogs sorted by size and type, spontaneous human combustion. You may feel any or all of these things can't be. Well, if so, please investigate the evidence for yourself, perhaps starting with the catalogs of reports by Corliss. My argument is that science has blind spots. Important observations are ignored, either because they don't fit in with prevailing theory, or because they can't be observed or easily reproduced in the lab on demand. There are, of course, plenty of sensationalistic and uncritical reports in this area, as well as just plain hoaxes, delusions, and hallucinations. But that doesn't mean there isn't also careful collection, curation, and analysis of data. Who knows what unexpected phenomena are yet to be discovered?